Good afternoon, fellow enthusiasts. My name is Sonali, and I'm going to present a tech talk on the topic developing a better Batmobile, but with MBSE. So I haven't really prepared the classic PowerPoint slides because I really wanted you guys to have a look at the tool that we are using for model-based systems engineering. So, but let's start with a little background. So today we are going to dive into the journey of model-based systems engineering, and which will be guided by none other than the Dark Knight himself, Batman. So in the city of Gotham, there's a new threat looming. Joker has hidden some high-tech technology around the streets, and now Batman realizes that he needs an upgrade for the Batmobile. I know the Batmobile is already a really high-tech machine, but one thing Batmobile is not yet, that is autonomous. How about having an autonomous Batmobile which could help Batman scan the streets autonomously and neutralize the technology that the Joker has hidden? So today we are going to see how Batman could actually use MBSE and Cameo Systems Modeler, that's the tool that I'm showing you guys, how he could actually use this and achieve this goal. So let's start. This here is an activity diagram, and let's start with the agenda. So I'm just going to double-click here, and we go inside the agenda where we see, we start with what is MBSE. Some of you know it, maybe some of you don't. I'll just adjust this zoom here. Right. So let's start with what is MBSE. I'm sure some of you have heard before and some of you haven't. So model-based systems engineering MBSE stands for model-based systems engineering. To understand what is MBSE, we need to go 2 steps back and try to understand what's systems engineering. So imagine now Batman wants to build this Batmobile, right? He can't just randomly go and start putting stuff together. That would be a real hassle. This is where systems engineering comes into picture. Systems engineering is like having a detailed plan. So imagine Batman having a detailed plan and like a master checklist where he has all these components that he's going to need for his Batmobile. And he uses all these sticks, and then he knows that, okay, now I'm supposed to build a better Batmobile, but with all these components. So talking about systems engineering, traditionally, it has always been document-based. When I say document-based, document is the hero of the story. So all the requirements, specification, everything is in the documents. Imagine Batman being swamped in all these documents, millions of documents having all the data around him. Now, here is where the model-based systems engineering comes into picture. It's basically having all this information which we have in the form of document, but now in a digital form, that is the digital model. It's very similar to what I'm showing you guys. This is also a model that I have prepared in Cameo Systems Modeler. So imagine having all this information, but in a digital form. So now Batman is actually sitting in front of his computer, having this model where he's going to have all the information in this model. So this is model-based systems engineering, where in document-based, it's instruction manual in the paper form, but in model-based, it would be a digital model. The importance of MBSE would be like it helps us get a virtual model of the system. So imagine that Batman can actually also foresee how his better Batmobile or autonomous Batmobile is going to look in the end. How it's going to function, what are the tests, what are the scenarios. He can do this in very earlier stage. So this helps him also to identify whatever problems one can face in the end, but in the very early stage of the product development. So also simulation of all probable scenarios, just like I said, it's also possible to actually have all scenarios simulated, and that's why identifying all the conflicts that are there. Okay, going back to the second point that we have. So I'm just going back, and now the second point is why MBSE for autonomous vehicles. So why am I focusing so much on MBSE for autonomous vehicles? There are like so many other technologies as well. MBSE for autonomous vehicles, there are some aspects that I want to talk about. There's precision and reliability. So since it's an autonomous vehicle. It has a lot of parts. It has a lot of interconnected systems, sensors, which are supposed to work with one another flawlessly. And this is where precision or precise digital model comes into picture, where it helps, MBSE helps to create this digital model very precisely, so that Batman is sure that the Batmobile, which is functioning, has all the precision. That's why it's also making it more reliable. Because we know it's all precise, all the components work with each other with all precision. That's why it's also making it more reliable. And that's where you also see predictable responses of the system. Then there's also seamless integration. So talking about MBSE tools, there are also many other tools that we have. And right now, it's in the production, in the development phase, where MBSE can also have very seamless integration with other tools. That gives us a lot of possibility to discover what MBSE tools offers. For example, there's modeling parts in a cohesive manner and also early detection of conflicts. Then there's iterative development. So Gotham City's challenges are ever evolving. There are going to be new challenges all the time. The advantage of MBSE would be that Batman can actually make quick fixes in the model whenever he needs. And that's like the biggest advantage. Because every time, if there is a new need, a new scenario, he can just go to the model and fix it quickly. So this is why iterative development is also one of the important aspects that we want to consider. Then there is simulation and testing. In simulation testing, again, we are testing all the scenarios that are going to be possible in the end. If Batman's going to use it only in Gotham City, or if he also wants to use it for some other reason, all this testing can be done beforehand on this model. Last but not the least, it's the enhanced safety and security. So talking about any product, not just Better Batmobile, but any product, it's really important that in the end, we have the safe and secured product. With MBSE, again, because we are doing a lot of modeling at the beginning of the product development itself, it is easy to identify all the safety protocols and if it is safety protocol compliant or not. This can be also found out very early in the stage, and whatever the tweaks and tweaks are supposed to be done, they can be done. So this is why Batman should be using MBSE for autonomous vehicles. Then now, I would like to actually enter into the model that I've created for you guys. So imagine that we have, the block here is basically, this is a use case diagram. Maybe some of you guys know what use case is. We have a use case that is drive autonomously. This is what Batman wants to do with our system. System is the Better Batmobile. Batman is the actor. And now you also see here on the right, there's a requirement. The requirement is the Batmobile should drive autonomously. So with MBSE, he's also able to actually integrate all the requirements that he has under one roof. So he doesn't have to, look at all the requirements and see if they're satisfied or not. He can actually perform this in the tool itself and make sure that all requirements that were there are traced, are satisfied, and are modeled. This was about the requirements engineering, and this is the behavior part that we are doing. Then I go deep into drive autonomously use case, and then I enter an activity diagram. This is where he can actually describe the actions that are going to be there. For example, he wants to now develop this autonomously. Here's Batman, and on the other side, there's the Batmobile. And the first action is jump on Batmobile. He starts the Batmobile, select the destination, and parallelly he's being cool and calling Catwoman because now his Batmobile is autonomous. And the Batmobile is, of course, he's accelerating, detecting objects, dodging, steering. It will brake at the destination, and then Batman will jump out of this. This is just a very basic example. It's not even complete. It's just a very basic, raw example of how the activity would look like. Then this was the behavior part of the model. There's also structure. So once Batman has already modeled how the behavior would look like, he can actually go and figure out a structure what do I mean by structure? How the Batmobile would look like. So the Batmobile would have a steering system, it would have an object detection system, braking system, acceleration system. Again, this is a very raw example, but I just want to show you guys that how the structure part can also be covered by model-based systems engineering. Yeah, so this was the model that I've prepared. Now going back to the agenda, talking about challenges in MBSE. So there is interoperability. As I mentioned about MBSE, like there are so many parts that we are talking about, right? It's an autonomous vehicle. It's a high-tech technology which has like so many sensors and so many systems. They are supposed to work with one another flawlessly. And this can be a bit challenging to actually get this interoperability part together. But again, these are the current challenges and there will be progress in future. But it is, yeah, one of the current challenges. Then there is data management. Because we are talking about autonomous vehicles, of course, there has to be so many sensors, so many systems that are there on board. They generate so much of digital data. Managing this data is a task because it involves just a vast amount of data. That's why data management is another challenge. Then we have cultural change. Now, there are companies who are doing traditional document-based systems engineering. Now, for them to move towards model-based systems engineering is a challenge because this is a part where organization has to play a role to make this change happen. They need to make people believe that, you know, model-based has some better advantages and so they need to now make a paradigm shift to model-based. So this is again a challenge. And cybersecurity concerns. Of course, because we are talking about digitalization and we have a digital model, it is also a bit challenging to have all the parts as for the cybersecurity concerns. So this is again one of the challenges. Talking about future trends, I'm sure everyone of you here knows about AI, ML. So of course, there is a lot of scope where we can actually integrate AI and ML with model-based systems engineering. Because AI is then now capable of summarizing such vast amount of data, predicting system behavior. All this can be really, really interesting when we talk about model-based. Then there is digital twins. Digital twins is like having virtual replicas of the physical system. Imagine Batmobile learning from its own digital twin. It would be really cool. Then we have IoT integration. There's Internet of Things where we are connecting the digital model with other parts. So MBSE can help having these interconnected systems also interact with one another autonomously. So this would be a part of IoT integration. Then last is the collaborative MBSE. In collaborative MBSE, we would have people working from different geographical locations and still being able to collaborate together using the power of collaborative MBSE. So imagine having Batman building a Batmobile which can learn from its own digital twin, which optimizes the performance with the AI algorithms, which is really seamlessly able to connect to the Gotham's smart infrastructure, at the same time having the highest level of cybersecurity. This is what we are looking at when we look at the future trends in model-based. And lastly, I would like to conclude my talk in the last minute. Now we have seen how Batman has actually used model-based systems engineering to create an autonomous Batmobile. And now the streets of Gotham are safer than ever. And yeah, he was successful in using Cameo Systems Modeler and using model-based systems engineering. Thank you.